So this is going to be the ninth section of the second chapter of geometry. This is going to be about using that parallel angle relations we talked about last video and sort of using them to improve some problems and whatnot. So we're going to talk about the converses in this situation. So if you don't remember, the converse is the flipped form of a statement. So for instance, we have this, which would be the transversal statement, right? If parallel lines are cut by a transversal, then the corresponding angles are congruent. So this says that basically what we talked about last video, this is the corresponding angles theorem. So this says that if I have two parallel lines and they're cut by a transversal, then the corresponding angles, like this angle here and this angle here, are congruent. And again, we talked about that last video. That's a true statement there. This is the corresponding angle theorem. The converse would be switching these statements. So if the corresponding angles are congruent, then the lines are parallel. So that means that if I have this, so if I have that these two angles are congruent, then I know that these two lines are parallel. So the issue with these, the difference is what you're assuming. Here, you're assuming the lines are parallel, and therefore the angles are congruent. Here, you're assuming the angles are congruent, and therefore the lines are parallel. So you use the theorem when you want to prove angles congruent. You use the converse when you want to prove that lines are parallel. Remember, this symbol is for parallel. The 11 basically means that two lines are parallel. So that's the difference between the converse and the theorem. You use the theorem when you want to prove angles are congruent or supplementary in the case of consecutive, and you use the converse when you want to prove that lines are parallel. So these are what they are said verbatim. Again, this is just the reverse of what we talked about last video. So exterior angles converse means that if two alternate exterior angles are congruent, then the lines are parallel. Alternate interior angles, again, if the alternate interior angles are congruent, then the lines are parallel. Consecutive is the only one that's a little bit different because remember, consecutive is supplementary, not congruent. So consecutive says that if the consecutive inside angles add to 180, then the two lines are parallel. And then again, we have the perpendicular one we talked about last time, where if these two angles are perpendicular to this transversal, then the lines have to be parallel. So let's go ahead and see how we can use some of this stuff here. So the first one is more algebraic, and then we'll get to the proof stuff. So this says, okay, what theorem would you use to prove that the lines are parallel? So angle 1 is congruent to angle 2. So this is the given. So if we know that angle 2 is congruent to angle 8, so if we know that angle 2 is congruent to angle 8, what theorem could we use to prove what line's parallel? So the first thing you have to think about is that if you have two angles, what is your transversal and what are your parallel lines? So in this case, for 2 and 8, A and B would be the two lines I want to prove parallel. L would be the transversal. How do I know that L is the transversal? Well, because it's a part of both angles. The line that is a piece of both angles, so L is the side of this angle 2 down here, and L is the side of this angle 8 down here. So if L is a piece of both angles, then L is the transversal. And the other two lines would have to be the lines you're actually proving. So in this case, I would prove that A is parallel to B. Now the second part, or the first part of it, is actually what theorem would you use to prove that? So you know that L is your transversal, therefore A and B are your target parallel lines, but how would you know that they're parallel? Well, if 2 is congruent to 8, remember congruent means I'm either going to be using the corresponding or the alternate angle converse, right? So in that case, 2 and 8 look to be alternate interior angles, right? 2 is on the up, 8 is on the down, and they're inside the two lines A and B. So that means that they're alternate interior angles. So I would prove that A is parallel to B by alternate interior converse. Again, and the reason I'm using converse is because I'm proving that the lines are parallel. If I was given this in reverse, so let me just do the backwards version here. If I was told that given A and B are parallel, how would you prove that angle 2 is congruent to angle 8? I would say the alternate interior angle theorem, because I'm proving that the angles are congruent. Here, I'm given the angles are congruent, and I want to prove that the lines are parallel. So again, converse if you want to prove parallel, theorem if you want to prove congruency, or in the case of consecutive, supplementary. Let's try 2 more here, just so we get. I'm not going to do all 6 here, just because that'll take too long, but I'll do like 3. So what about if we choose angle 3 and 11, which is the next one here, 3 and 11. So here's angle 3. Here's angle 11. The first thing is to establish what is our transversal. Well, then I see angle 3 and angle 11 both share angle or line A here, right? Line A goes through angle 3 and angle 11. So line A is my transversal, which means that line L and line M have to be my lines that I want parallel. So I'm going to try to prove that M is parallel to line L. Those are my two parallel lines. How do I know that they're parallel? Well, let's take a look at what kind of angles 3 and 11 are. So 3 is in the lower right-hand corner of its set. 11 is in the lower right-hand corner of its set. So that's a corresponding situation, right? So this would be corresponding, C-O-R-R, angles converse. Again, converse because I'm trying to prove that lines are parallel, not that angles are congruent. I'm given that angles are congruent. I want to prove that the lines are parallel. So once again, establish your transversal. Therefore, you know the two lines you want to be parallel, and then figure out what type of relationship the angles are. And if you notice here, I can just basically completely ignore line B here. So in each of these situations, even though there's 4 lines, there's one of them that I completely ignore because line B has no impact on any of these angles down here. So that's why I don't use it at all. And then lastly, let's try 1E here. This one right here. Let's see here. So angle 8 plus angle 13 is 180. So here's angle 8. Here's angle 13. And I know that they're going to add 180. So they're not congruent, but they add 180. So let's first figure out my transversal. So 8 and 13, they both are split by line B here. So line B is on the bottom of both of these angles, or on the right, I should say, of both these angles. So line B is my transversal. That means line L and M, again, are the ones I want to focus on. So line L parallel to line M. Now, how do I know that? Well, if they add to 180, it can't be alternate or corresponding, right? Because alternate or corresponding are congruency. So that means it has to be consecutive. Or, again, if you prefer the word same side, you can put SS, same side. Interior angles converse. Because the consecutive or same side angles are the ones that add to 180. So again, this says that if you know that these angles are supplementary, if you know that they add to 180, what lines have to be parallel? And that has to be lines L and M. Because if lines L and M weren't parallel, then those two angles wouldn't add to 180 like I know, because again, it's telling me that they do. So again, it's mainly just identifying what type of relationship you have with those two angles, and then identifying what lines would be parallel because of it. So it's not that much detail going into it. Again, if you still have trouble with this, that's fine. That's why we practice. You can always let me know if you need more help too. But that's the idea here. So let's keep going here and see if we can't practice this a little bit more. So we could throw some algebra in here too. So it says that, okay, you have the situation. What would y need to be in order to make these lines parallel? So these lines may or may not be parallel right now. We don't know. But how big does y need to be in order for these two lines to be parallel? Let me do a mic check here because I'm not sure Okay. I was going to say, did I just do this all with my mic off? Anyway, so what do these need to be in order for lines F and E to be parallel? Well, if lines F and E would be parallel, that means that if there's a right angle here, that means that all of these would have to be right angles as well. Because remember, if there's a right angle here, that means there's a right angle here, a right angle here, and a right angle here. And if these are to be parallel, that means that same situation has to happen here. These all need to be right angles. These should be more squarey. So that means that this has to be 90 degrees. Okay, so let's set it equal to 90 degrees. 4y plus 10 equals 90. Because this is what has to happen in order for these two lines to be parallel, because it's the perpendicular angle converse, right? Or perpendicular line converse. If the line up top here is perpendicular to the transversal, the line on bottom here has to be perpendicular to the transversal in order for them to be parallel. So you just subtract 10. This is actually the same thing we did in the last video. It's just that you're basically going backwards essentially without really going backwards. So 4, and you get y is 20. So y has to be 20 in order for these two lines to be parallel, because that would be the one that makes this perpendicular like it should be. I'll go through a few more here as an example. Come on. So let's do 2 more here before we get to the last little bit. So let's do, again, a set of these here. So it says, okay, you have the situation here. If you're given this information, what two lines would be parallel, if any, and then what theorem would you use to justify that? So it says, okay, if angle 1 is congruent to angle 3. So if angle 1 is congruent to angle 3. So first off, establish a transversal. So what line goes through both 1 and 3? Well, that would be line L. Line L goes through 1 and 3. So if line L is my transversal, what two lines have to be parallel? J and K. So I want to prove that J is parallel to K. Now, how would I justify J being parallel to K if one is congruent to 3? So that's when you ask yourself, okay, what kind of angles are 1 and 3? Are they alternate interior? Well, no, because 1's on the outside. Are they alternate exterior? Well, no, because 3 is on the inside. Are they consecutive interior? Well, no, because 1's on the outside. Are they corresponding? Well, that is a yes. Because if I look at this, angle 1 is on the top left of its set of 4. So if I look at this set of 4 here, angle 1's on the top left. If I look at this set of 4, angle 3 is on the top left. So because they're both in the same situation, the same spot, that means it's going to be a corresponding angles converse theorem. Or not theorem, but the corresponding angles converse situation. So again, establish a transversal, find out what two lines are your target lines, and then figure out what type of angle relation the two angles you're given have. I'll let you guys try the other ones. Again, let me know if you have any questions on them by email, because we did 3 of these already, so I don't want to spend too much more time on that because we have other stuff to get through, and I don't want to make this video too terribly long. So let's do the algebraic one here. So it says find x so that m is parallel to n, and then identify what postulate or theorem we used. So find x so that m is parallel to n. So I want to make these two lines parallel. I want to know what do I have to make x so that these two angles would agree with that. So what kind of angles do we have here? Because we don't need to establish a transversal because it's already going to tell us what two lines we need. So m and n are the two lines we're looking to get parallel. These are the two angles I have. What type of relationship do these two angles need to have in order for them to be parallel? Well, let's see. These are exterior angles, and they're alternate. So if they're alternate exterior, so alternate exterior, that means that they have to be congruent if the lines are to be parallel. If I want to make these lines parallel, the alternate exterior angles have to be congruent. So if I want to know what x has to be, I'm going to set them equal to like I want them to be. I want the first angle to be congruent or equal to the second angle. That way the lines are parallel. So I want to figure, okay, what x has to be in order to make this situation happen, and that's when you go back to algebra and you solve it. So minus 2x, 2x minus 23 equals 17. Add 23, add 23. You get 2x is equal to, let's see, that would be 40. Divide by 2, and you get x is equal to 20. There we go. So that's how you would solve that one. Again, you figure out, okay, what type of angle relationship do these have? Are they going to be, just like the last video, are they going to be congruent? Are they going to add to 180? Are they going to add to 90? And then set up your equation and solve. So it's really no different. It's just the wording is a little bit different because you're going from this prospect of you want the lines, not instead of given, you want the lines to be parallel. Therefore, what relationship has to work here? So the wording might be different, but the actual procedure isn't too different from the last video we had on the algebra stuff for this. So now let's finish this off with some proofs here, okay? So when you're proving lines are parallel, again, proving lines are parallel means you're going to be using converse, right? Proving lines parallel means you're using the converse. You're looking for one of usually 3 situations. Corresponding angles, you want to make sure they're congruent. Alternate interior or alternate exterior angles, so alternate angles you want to make sure are congruent. Or consecutive or same side angles you want to make supplementary. Now, you do have the use of vertical and linear pair angles. Remember, vertical angles form that X pattern, and they're always going to be congruent. So top and bottom are congruent, left and right are congruent. Linear pairs form that Y pattern, and they say that angle 1 and angle 2 add to 180. So these are going to be helpful into getting to these situations. So you're going to be starting with a situation where you want to prove that one of these relationships exists, and then you can say that the lines are parallel because of that. So let me show you one in action here. So we're given that angle 2 is supplementary to angle 3. So we know that angle 2 plus angle 3 adds to 180. And we're given that angle 1 is congruent to angle 3, and we want to prove that AB, so this line right here, AB, this top line, is parallel to DC, this bottom line. Now, we do not know that J is parallel to K. So we don't know that J and K are parallel. All we know is what's given to us up here. So I'm going to do a little bit of shorthand here. I'm going to say, okay, that is my given, just to save some time on the video. And then I'm going to try to work to say, okay, if I want AB and DC to be parallel, I want to get either congruent or corresponding or alternate angles congruent, or I want to get some consecutive angles to be supplementary. So the first thing I like to do is start with my given and say, okay, if angle 2 is supplementary to angle 3, what I should do first is say that, okay, if that's true, that means that angle 2 plus angle 3 equals 180. Why? Well, because that's the definition of supplementary. I'm going to put SUPP for supplementary. So because they're supplementary, that means they have to add to 180. So I'm just going to write out that sum there so I have that to work with. Now, looking at my given, I also have that angle 1 is congruent to angle 3. Now, what does that mean here? Well, that means that I can swap out angle 1 with angle 3 and vice versa anytime I want. Well, if I have an angle 3 down here, let's just make that swap and see what happens. If I can swap them out, might as well put it to use, right? So if I'm given the option here, I might as well just swap this and say angle 2 plus angle 1 equals 180. Why? Well, because of substitution. Again, I'm swapping something out, so it's a substitution situation. Which, by the way, if angle 2 plus angle 1 equals 180, that also means that angle 2 is supplementary to angle 1. And again, this is by definition of supplementary, just to have that out there. So angle 2 plus angle 1 is 180, therefore angle 2 is supplementary to angle 1, and vice versa, technically. Now, where does this leave us here? So let's look back at my diagram here. So I know that angle 1 was congruent to angle 3, and then I knew that angle 1 plus angle 2 adds to 180. So angle 1 and angle 2, they both add to 180. Well, take a look at what that means here. If angle 1 and angle 2 add to 180, and again, keep in mind I'm looking for this top line and this bottom line to be congruent. Well, if that's the case, those are actually consecutive interior angles, right? Angle 1 is the consecutive interior on the AB side. Angle 2 is the consecutive interior on the DC side. And that's exactly the two lines I want. I want AB and I want DC. So if these two add to 180, that means that these two lines are parallel. I can actually make my proof statement right here. AB parallel to DC. Why? Well, because I have the consecutive interior angles that are supplementary, or in this case, I'm going to put converse. Because what this says is that if you have two lines, like let's say, I don't know, AB and DC, if you have two lines and their consecutive interior angles add to 180, that means the two lines have to be parallel. So that's kind of what I have here. I got that angle 1 and angle 2 add to 180. I saw that they're consecutive interior, and therefore that's when the switch happens and says, okay, if they add to 180 and they're consecutive interior, bam, the lines have to be parallel. So again, the goal here is to take your given, get one of the four angle relations, either corresponding, alternate interior, or consecutive. I guess there's five: consecutive interior, consecutive exterior. But get one of those relations and then show that, hey, this happens, therefore the lines have to be parallel. In this case, the relation I got was consecutive interior, and therefore I was able to show that the lines are parallel because of that. So let's try this one more time here. Given that L and M are parallel. So I know that L and M are parallel. And I know that angle 2 is congruent to angle 4. So angle 2 is congruent to angle 4. Prove that J and K are parallel. So I'm going to, again, do my shorthand here. So I'm going to highlight this and put it down here as my given. Just to make the video a little bit more cleaner, you should always write out your given in words. I'm just going to do this to make my video a little bit shorter and more manageable. So I know that 2 is congruent to 4, and I know that this. So this is a big given right here. L is parallel to M, because this means I can use all the corresponding alternate consecutive theorems for these two lines here. And that's going to help me get something with J and K. So if I have 2 congruent to 4, this is kind of going to be how you set up your theorem, how you know where to go. If you have 2 congruent to 4, that means that you're probably going to want to do something else with either 2 or 4, so you have something to substitute in. So this is kind of like saying to you, okay, somewhere down your proof, you're probably going to swap out an angle 2 with an angle 4. So get something that has an angle 2 or angle 4 in it, and then swap it out for the other and see where that leaves you. And that's probably going to help you get to the end here. So let's see here. If L is parallel to M, what can I say about, let's use angle 2. What can I say about angle 2 if L is parallel to M? Well, if L and M are parallel, that means 2 and 3 are congruent, right? Because 2 and 3 are alternate interior angles. So I can say that angle 2 is congruent to angle 3. Why? Well, because of alternate interior angles. Now, notice here I'm not putting converse. I'm going to put theorem. Why do I put theorem? Well, because I'm proving that the angles are congruent, not that the lines are parallel. I know the lines are parallel, L and M. I want to say that the angles are congruent. So if you want to say the angles are congruent, you use the theorem. If you want to say the lines are parallel, like what we'll do at the end, then you use the converse. So I know that 3 is congruent to 2 now. So 3 and 2 are congruent. That also means, by the way, again, by substitution, that angle 4 is congruent to angle 3, right? By substitution. Because, again, if 2 is congruent to 4, that means I can swap out any time. So I just did that swap there. So I know that 4 and 3 are congruent. Well, hold on here. That's a big deal. Because if 4 and 3 are congruent, let's look at back at my lines here. I want to prove that J and K are parallel, right? So here's J, here's K. I want to prove that these two lines are parallel. Well, if 4 and 3 are congruent, are those any type of special angles here? Well, if we look here, 3 is in the top right of its set of 4, right? And 4 is in the top right of its set of 4. So those are corresponding angles, 3 and 4. 3 and 4 are corresponding angles. And if the corresponding angles are congruent, that means the lines that make them, J and K, are parallel, which is what I want. So that's where I'm going to end it at. So J parallel to K. How do I know that J is parallel to K? Well, because of the corresponding angles converse. Remember, converse here, converse. The converse here, because I'm proving that the lines are parallel. So if my statement is the lines are parallel, converse. If my statement the angles are congruent, alternate interior angles theorem. So congruent, theorem, parallel, converse. Think about it that way. But this, again, takes a little bit of thinking. It's not like your typical, solving an algebra question here. You have to kind of always keep in the back of your mind as, okay, do I have any of these 5 angle relations? So if you want to, after every step you do, check to see, do I have any corresponding alternate or consecutive angles that I can match up here and prove the lines are parallel? After I said that 2 was congruent to 3, I didn't have any set up yet. But once I said that 3 was congruent to 4, well, that right there triggers it and says, okay, 3 and 4 are corresponding. So therefore, that the lines had to be parallel because I have a corresponding relationship I didn't have before. I didn't know that 3 was congruent to 4 at first. Once I proved that it was congruent by substitution, then I have a corresponding angle match, and therefore my lines have to be parallel. Now, this is not the only way of doing this proof. There's a few different ways you could have gone about this proof, so I'll leave it to you if you want to think about a different way to do it, and maybe send me an email saying if you think you got it or not. You can. But there's actually a few ways you could go about proving this, which might be a good exercise for practice. So I'll leave that to you if you want. So let's do one more here. Given that 1 is congruent to 3 and that AC is parallel to BD, prove that AB is parallel to CD. So let me make my lines here. Again, I'm going to be lazy just to make the video more manageable and say given. All right. So let me mark this up here. So 1 is congruent to 3. So angle 1 is congruent to angle 3. And I know that AC is parallel to BD. And I want to prove that the top and bottom are parallel. So I want to prove this top line and this bottom line are parallel to each other. All right, so we know that 1 is congruent to 3. That's great. Now again, since I'm given this, that usually means that's kind of like a little bit of a clue saying, hey, try to get something that involves angle 1 or try to get something that involves angle 3 so you can make that swap. So use the given, think of the given as hints. They're hints on how to go through your proof here. So if angle 1 is congruent to angle 3, what else can I say about some of these angles here? Well, again, that lies within this one. If AC is parallel to BD, look at angle 3 and angle 2 here. Angle 3 would be, if I extend this out a little bit, so a little bit more there, a little bit more there, a little bit more there. Angle 3 is in the top right of its set of 4. Angle 2 is in the top right of its set of 4. And because I know that these two lines are already parallel, these two side lines, I can then say that angle 2 is congruent to angle 3. Now again, this is not the converse, this is the corresponding angles theorem, because I'm saying that the angles themselves are congruent. So I already knew that AC and BD are parallel. I already knew that these two lines are parallel. Therefore, I know that if angle 3 is over here, that means angle 2 over here has to be equal to it, because again, they're on the same position of their sets of 4. So I know that angle 2 is congruent to angle 3. Well, again, that usually means we're going to make a swap now, right? I have something with angle 3. I have a congruency up here that's waiting for it to be used to swap in. So I'm going to say that angle 2 is congruent to angle 1 because of, again, substitution. Now, after this, you're going to check to see, okay, do I have any consecutive interior angles? So I'm looking here. I don't really have any consecutive interior angles, no. Okay. Do I have any corresponding angles? Well, I had 2 and 3, but they already have these lines parallel, so those corresponding angles really don't help me much now. Angle 1 and angle 2 are definitely not corresponding because they're both on the inside, so that can't happen. Do I have any alternate angles? Well, that I do. Angle 2 and angle 1, those are alternate angles. They're alternate interior. Because if I'm talking about AB and CD, angle 2 and angle 1 would be alternate interior to those angles. And they do happen to be congruent. So if they're both alternate interior and they're congruent, that means the lines that make them have to be parallel, which is what I want. So AB parallel to CD. Why? Now again, this is where we use the converse because I'm proving that the lines are parallel. So alternate interior angles converse. And then that's QED. That's the end of the proof there. 3 triangle or 3 dots if you want. So again, the goal with these proofs, it's a little bit strange, I know. I keep saying that, but it's the truth. It takes some time for this to sink in here. The goal with this is to figure out, okay, using my given as clues, I want to set up a corresponding, a consecutive, or an alternate interior angle relation. Once I've set up a corresponding, consecutive, or alternate interior angle relation, I want to use that converse to then prove that the lines I want to be parallel are indeed parallel. In this case, it was AB and CD. So when you're doing these proofs, just look at it for a minute and say, okay, what are some potential alternate, consecutive, or corresponding angle relations I have here, and let me try to work towards making those happen. So again, sorry for a length of video here, but I had a lot to do here. Rewatch it if you need to. Go over some practice problems if you want to. Email me as always. Let me know if you have any questions. I'll be glad to answer them. Hopefully this video helped you out. Again, have a good day, night, or afternoon.